So here's our friend entitled No Exponential Pain, No Exponential Gain. So let's practice some rules and see what we can simplify. Well, if I have something with an exponent raised to another exponent, I simply multiply them. So this should be n to the 12 over 2, which is just n to the 6th. I'm going to distribute this to both things and get 27 to the 5/3 times p to the 6 times 5/3, which is 10, right? Because that's 30 divided by 3, which is p to the 10th. And 27 to the 5/3, that's the cubed root of 27 to the 5th. The cubed root of 27 is 3. 3 to the 5th is 81 times 3, which I think is 243. So it's going to be 243 p to the 10th power. Over here, 25 to the 3/2 and b to the 6 to the 3/2 should be 25 to the 3/2 times b to the 9th, because that's going to be 18 divided by 2. That's the square root of 25 cubed, which is 5 cubed, or 125b to the 9th. 64m to the 4th of 3/2, that is going to be 64 to the 3/2 times m to the 6th. Multiplying 3/2 times 4. And 64 to the 3/2 is the square root of 64, which is 8 cubed. And 8 cubed is, I don't know. You'll find that on your calculator. 8 cubed times m to the 6th. Find that. Okay. From here, I think you can probably do these. We'll look at this example right here. This is going to be n to the negative 12 over 2, or n to the negative 6th, or 1 over n to the 6th. Number 12 here would be 64 to the negative 3/2 times m to the negative 12/2, which is 1 over 64 to the 3/2 times m to the 6th. And that is the square root of 64 cubed again, which would be 1 over 8 cubed times m to the 6th, which is basically what we had before, but with a negative exponent. So you'll find 8 cubed, and then you'll be good to go from there. Okay, there's some more examples here. Maybe we'll do one more. This one would be 81 to the 5/4, and then x to the, let's see, negative 12 divided by 4 is negative 3 times 5 to the negative 15th. And 81, the 4th root of 81 is 3. 3 to the 5th is, I think, 243. So that's going to be 243 divided by x to the 15th power. 17 says, A, graph f of x if n is positive, odd integer, and a is less than 0. So one example would be like negative x cubed, right? Because we've got a positive odd integer and a is less than 0. So that would look like this. Graph f of x if n is a positive even integer and a is less than 0. That would be something like negative x squared. So that would look maybe something like this. D says, I don't know what happened to C. Graph f of x, oh dear, D, E, F, goodness gracious. D, E, F. So there is no C, I guess. So D, graph f if n is a positive even integer and a is greater than 0, so that would look like x squared. E, graph a times x to the 1 over n if n is a positive odd integer and a is greater than 0. So that would be like x to the 1/3. So that would look something like this. And the last one is 1 over n if n is positive even integer and a is less than 0. That would be like negative x to the 1/2, or which is the same as negative square root x. And that would look like this. Then it says, on each of your graphs, draw y equals k such that f of x equals k has no solutions, or indicate that it is not possible. Not possible. Here's a line where there are no solutions. Here's a line. Here's a line. Here it's not possible. So the odd roots, you're always going to have solutions. The even power functions and root functions, you might not always have solutions. That's pretty much what it's getting at. And that pretty much takes care of it.